I'm Dr. K. Anandan, Associate Professor, Department of Physics. Today we are going to discuss about a different type of transformer and how the transformer is going to work and applications of transformer. That and all we are going to discuss today. The transformer is basically electrical machines which will be transfer the electrical energy from one circuit to another circuit without change of frequency. The transformer is working based on the principle of mutual inductance. So what is meant by mutual inductance? The mutual inductance means if you pass the current in one circuit, there will be a magnetic flux will be formed. The flux will be connected to the adjacent circuit. So when the magnetic flux is connected to the adjacent circuit, due to the change of flux, because we are passing the alternative current, when the alternative current passing in the one circuit, the magnetic flux direction will be alternatively changed. So the change of flux when it's connected to the adjacent coil or neighbor winding, there will be some EMF will be induced. So when passing current in one circuit, the EMF induced in the adjacent circuit, which is called the mutual inductance. So this is a basic principle to working of the transformer. When we are passing the current in one coil, the flux will be created. So the adjacent coil, when it's bring near to the previous coil, so flux due to the flux linked with the adjacent coil, EMF will be generated in the next coil. That is a mutual inductor. So the construction of the transformer. The construction of the transformer, one rectangular core will be there. One side the primary coil will be there, and then other side the secondary coil will be there. So these two coils magnetically it is connected, but electrically it is separated for both coils. When we are passing the current in the primary coil, due to the magnetic effect of electric current, EMF, that is magnetic flux will be generated. So the flux will be linked with the adjacent coil through the core. Okay, so when we are passing the current in the primary coil, the flux will be created, right? So here, not all the flux will be linked with the secondary coil. Some of the flux will be linked with the secondary coil, some of the flux are not linked with the secondary coil. Okay, so due to the flux, which one is connected to the secondary coil, due to that flux only the EMF will be generated in the secondary coil. So those are the fluxes linked with the secondary coil. That flux is called as a useful flux or the main flux. Okay, so those are the fluxes are not linked with the secondary coil. Those flux is called as a leakage or wastage. So the EMF which is generated in the secondary coil, that is called the mutually induced EMF. So the alternative current we are passing, right? So due to the alternative current, the flux direction also continuously will be changing its direction. The linked coil, that is a secondary coil linked with the flux, the EMF will be generated in the secondary coil. Changing its direction of the alternative current in the primary coil, so the flux direction also is changing continuously. So due to that, EMF direction in the secondary coil also will be changing. So here, EP is the EMF in the primary coil. ES is the EMF in the secondary coils. NS is the number of turn in the secondary coil, and NP is the number of turn in the primary coil. So if number of turn in the primary coil, the number of turn in the secondary coil, if it is same, you just assume the number of turn in the primary coil, number of turn in the secondary coil, if it is the same, if all the fluxes are linked with the secondary coil due to the current in the primary coil, what are the fluxes created? Then all the fluxes are linked with the secondary coils mean. Okay, so here there is no losses. Okay, so all the complete EMF, whatever is generated in the secondary coil, that is equal to the primary coil EMF. Okay, so that is called ES by EP equal to NS by NP. That is equation number 1. For ideal transformer, there is no losses. What is the input power? That is equal to the output power. That is an ideal transformer. So the IP equal to ES into IS. So IS, IP is the current in the primary coil and the secondary coil. Okay, so ES by EP equal to IP by IS. That is equation number 2. So from the equation number 1 and 2, we can get the equation number, that is the K factor, that is a transformer ratio. So based on the K value, we can get the two different type of transformer. One is a step-up transformer, the another one is a step-down transformer. the step-up transformer, you can, by the word itself, you can know what does mean by step-up transformer. Step up, which means when we are passing the current in the primary coil, in the secondary coil, if you get the more amount of EMF than the primary coil, that is called the step-up transformer. So what is the construction of the step-up transformer? The construction of the step-up transformer is the number of turn whatever is there in the primary coil and the number of turn whatever there in the secondary coil, that will be more. Which means in the secondary coil number of turn will be higher than the primary coil. That is a step-up transformer. So it's a opposite for that is a step-down transformer. The number of turn will be more in the primary coil and the number of turn will be less in the secondary coil. That is called the step-up transformer. We will know about where we are using that the step-up transformer and step-down transformer. There will be a power plant where the electrical energies are produced. So that will be far away from us. Okay, so the electrical energy is generated. That electrical energy need to travel for the long distance. Okay, so the amount of energy whatever is produced there in the power plant, that is not enough to travel for the long distance. So at that time we have to use the step up transformer to have to increase the energy. So once we are increased the energy, that energy can travel for the long distance. Once it is a travel for the thousands of kilometers, and then the bulk amount of energy we cannot use directly to our home for the different purpose. Okay, so that we have to reduce that energy. So in the power plant, there we are using the step-up transformer. Here, after reached our surroundings, our area, we have to use step-down transformer. So we have to reduce the energy level up to the 240 volt, and then we can use that electrical energy. Hope you understood where we are using the step-up transformer and the step-down transformer. How we can calculate the efficiency of the transformer? What does mean by efficiency? How the transformer is producing the output. The ratio between the input and output, that is called the efficiency of the transformer. Actually, practically, there is no possible to get the ideal transformer, which means input power equal to output power. Okay, so always some energy losses will be occur in the transformer. Okay, so what are the losses will be there? How we can minimize the losses? We cannot remove the losses. There are different type of losses available in the transformer. Iron losses, copper losses, hysteresis losses and eddy current loss. Not all the flux will be connected to the secondary coil. Some of the flux will be connected to the secondary coil, that is the useful flux or the main flux. So the flux which is not connected to the secondary coil, that is the wastage or the leakage. Okay, so when we are using the core type of core, some losses will be occur. When we are using the shell type of core, so the primary coil, secondary coil, when we are using the when we are passing the current in the primary coil, maximum of the flux connected to this core connected to the secondary coil. So here the flux leakage will be minimized. By using the shell type of core, we can minimize this kind of losses. Copper or the ohmic losses. The copper and the ohmic losses, thickness of the wire. So to make a primary coil and the secondary coil, we are using the wire, right? You know that, everyone we know that what is thickness connected to the resistance. Okay, so if the thickness is very thin, the resistance will be more. The thickness is high, the resistance will be low. Okay, so if you considerably using the thicker wire to make the primary coil and the secondary coil, we can minimize this copper or ohmic losses. So current flowing through the primary coil and the secondary coil, it just lead to Joule's heating effect. Okay, due to the high resistance, it producing the heat energy. So that takes some of energy. Okay, so if a considerably thicker wire we are using, this kind of losses we can minimize. Then hysteresis losses. What are the material we are using? So we know that the direction of the current flow will alternatively be changing, right? Alternatively getting magnetization and the demagnetization, it producing losses in the energy called as a hysteresis loss. These losses can be minimized by using the core with the material having the least hysteresis losses. Okay, so alloy like mu metal or silicon steel used to reduce the hysteresis losses. Then the eddy current loss. So the eddy current loss, the varying the magnetic flux is producing the eddy current within the core. Okay, so this lead to the wastage of the energy in the form of heat. So the current, the eddy current flowing within the core itself, which is circulating mean, it produces some heat energy. Okay, so that we can minimize by laminating the core. Above this all, when the transformer is working, some vibration you can hear. So that is also getting, so just consuming some energy too while working of the transformer. So above this all, some vibration will be occur, that is also consuming some energy. So what we can conclude, finally, while transformer is working, while changing the current primary coil to secondary coil, losses will be occur. That losses we can minimize, but there is no ideal transformer. That is the conclusion of the transformer working and losses method to minimize the losses. We have discussed what is the transformer and what base in the transformer is the working, what is the different type of transformer is available, step up and step down transformer, and there we are using the step up transformer and the step down transformer, and what are the losses is available in the transformer while transformer is working, and what are the way we can reduce the losses in the transformer. Okay, so with this discussion, we are concluding this transformer topic. So the next day we will discuss some other topic. Okay, thank you.